that square. We're actually going to look at the third root, fourth root, fifth root, stuff like that. Okay? So finding the square root of a number and squaring a number are inverse operations. Okay? To find the square root of a number a, you must find a number with a square of a. Similarly, the inverse of raising a number to the nth power is finding the nth root of that number. Okay, so if I have x cubed equals 64, I know 4 times 4 times 4 is 64, so 4 has to be that cube root of 64. Okay, same thing with x to the fourth here equals 625. Your general rule, if I have a to the nth power equals b, then I multiply a so many times, n number of times to get b. So a is the nth root of b. So this pattern suggests the following formal definition of an nth root. For any real numbers a and b and any positive integers n, if a to the nth equals b, then a is the nth root of b. So an example, if I have negative 3 to the fourth power, I end up with 81. Okay, so negative 3 is a fourth root of 81, and 3 is the principal root. Okay, so do you remember when you take the square root of both sides, you add in that plus and minus value because you can have a positive answer and a negative answer? Okay, that positive answer is called the principal root, but you can also have this negative answer for one of your roots. So the different pieces in our radical for an nth root. We have the index, that's the number of the root. So say it was a fifth root. Your n number or index here would be 5. Why are you just saying random things? This symbol right here is called the radical sign. Okay, that's your radical. And the number within that radical is the radicand. So some numbers have more than one real nth root. For example, 64 has 2 square roots. That's 8 and negative 8. No. Yes, it's rain. Okay, so 64, shh, you guys, we're not talking. We're listening. 64 has 2 different square roots. So I can square 8 to get 64. I can also square negative 8 to get 64. Okay, so that's why it has 2 roots. When there is more than one real root and n is even, the non-negative root is called the principal root. Okay, so our principal root would be 8 in this case. Okay, so the non-negative answer is your principal root. So some examples of nth roots are listed below. Okay, I have the square root of 25 is 5. The negative square root of 25 is negative 5. Plus or minus the square root of 25 is plus or minus 5. Okay, so you want to keep that same symbol. You can just shut it off. Sorry. It's okay. All right, so I want you to flip to the back. We're almost to examples here. So suppose n is an integer greater than 1 and a is a real number. If a is greater than 0, you have one unique positive and one unique negative real root, or plus or minus the nth root of a. Positive root is principal root. Okay, if a is less than 0, you don't have any real roots. Okay, a is less than 0, you don't have any real roots because you can't take that square root of a negative number. You have imaginaries. If a is equal to 0, you only have one real root, and that is 0. Okay? So if I take the square root of 0, it is 0. If I take the fifth root of 0, it is 0. All right, we're going to actually simplify some of our roots now with our radical symbol. So example 1, we're simplifying. Letter A. I have plus or minus the square root of 16x to the 8th. Okay, I'm going to split that into two different roots here. So I'm going to split that into plus or minus the square root of 16 times the square root of x to the 8th. Okay, I know what the square root of 16 is, right? What is it? 4. So I end up with plus or minus 4. Now when I take the square root of x to the 8th, one way I like to look at it is I know this is a square root. Okay, so this is a 2, right? All I have to do is take my power and divide it by whatever root I'm taking it to. So all I have to do is take 8 divided by 2. That's 4. So I'm going to end up with x to the 4th power. Okay, so whatever that root is, since this was a square root, I divided that power by 2 to get my simplified answer. Okay, so that would be your simplified version of that first one. Okay, looking at letter B. Now this one I'm not going to split in two. I'm not going to find the entire quantity and multiply it out. It's not what I'm going to do. This is all this quantity q cubed plus 5 is raised to the 4th power. I know I'm taking the square root of that quantity. So again, I'm just going to look at my power attached and divide by my root number. Okay, so I have 4 divided by 2, that's 2. I still have this negative sign on the outside. I still have my quantity of q cubed plus 5. But what power should it be raised to? 2. Easy enough, right?
Yeah.
Okay, good. All right, letter C. This time it's not a square root, it's a 5th root. Okay, so there's this little 5 right here. Okay, that's a 5th root. So we need to take the 5th root of 243. I'm going to show you how to do that on your calculator. So if you have a calculator, take it out. I just want to show you how to do that really quick if you don't know. So since this is a 5th root and not a square root, I'm going to start by typing in 5. Okay, start by typing in 5. Now instead of this square root button that you see right here, okay, above the x squared, you're going to go to the one right above it where it has the x and then the root. Okay, so I want to press second and then that x root. Okay, that's indicating that I'm taking the 5th root of something. Okay, and then I can type in my number, which is 243, and press enter. So the 5th root of 243 is 3. Okay, so simplifying here, I have my 3. Then I have a to the 10th, and I want to take the 5th root of that. So again, look at your power, divide by your root. So 10 divided by 5, I end up with a squared. And then again for b, I have b to the 15th. Okay, I want to take the 5th root of that, so 15 divided by 5 is 3. Okay, anybody need help trying to figure out how to take the 5th root on their calculator? Did you guys all figure it out? If you have a calculator? Okay, then letter D here. I'm going back to a square root. Okay, when you don't have a number out front in your root, it is just a square root. So I have the square root of negative 16, x to the 4th, y to the 8th. What happens when I take the square root of a negative number? Do you remember from last year? Not positive and negative. It's an imaginary number. Okay, so if I have the square root of negative 16, square root of 16 is 4, right? But then the square root of negative 1 is I. Okay, that's your imaginary number. Okay, 4i. So now from here, I'm still taking the square root of x to the 4th. What do I end up with? X squared. Okay, and then y to the 8th, I end up with y to the 4th. And that would be my simplified answer. Okay, so don't forget if you're taking this an even root and it's negative on the inside, so your radicand is negative, it is imaginary. Okay, so if that radicand is negative in an even root, it is imaginary. Okay, questions on those first 4 problems? All right, we're going to make things a little more complicated here. So when you find an even root, okay, find an even root of an even power, the result is an odd power, okay? You must use the absolute value of the result. Okay, so if you start with an even root, okay, 2, 4, 6, 8, 10, 12, 14, 16, even root, and you start with an even power on the inside, so again, 2, 4, 6, 8, and you end up simplifying to an odd power, 1, 3, 5, 7, 9, something like that, you need to put absolute value around that odd power. Okay, because of your domain error. Okay, so if I have an even root, I have to end up with all positives. Okay, if I simplify to or result in an odd power, I can plug in negatives and positives into that. But with my original domain error, I cannot. So you need those absolute value symbol around that odd power. So we are going to do an example of this. So here I have the 6th root of t to the 6th. So again, this power, or this root is 6. That is an even power, an even root. In my radicand, t to the 6th, that 6 is an even power. Okay, so I'm starting with an even root and an even power. Now when I simplify this, what does it simplify to? T to the 1st. Is 1 even or odd? It's odd. So I resulted in an odd power. So that means I need to add absolute value bars around that answer. Okay, so I ended up with an odd power. So if I start with even and even, end up odd, you need those absolute value bars. Okay, questions? All right, let's look at B. Okay, I have the square root of 36. What's the square root of 36? It is 6. Okay, what's the square root of y to the 6th? Y cubed. Again, you just take your power, divide by your root number. So 6 divided by 2 is 3. Now, since this was even, right? 2 is even, 6 is even, 3 is odd, right? So I need to add in absolute value around that y cubed. All right, I want you guys to try C and D. Try C and D. Simplify those two. Just like we did above. So keep it all in parentheses and then change the exponent. Don't forget to look if you need to use those absolute value bars. Check to see if you started with an even root and an even power and ended with an odd power. All right, what is the fourth root of 16? It's 2. The fourth root of 16 is 2. Okay, we're not taking the square root of 16. That would be 4, yes. But it is the fourth root of 16 that we want to find. That is 2. Okay, next I have my quantity here, x minus 3. Okay, that's raised to the 12th. Okay, we're taking the fourth root of that, so 12 divided by 4 is 3. Okay, this is an even root, right? This is an even power. This is odd. So what do I need? So that should be your answer. Letter D now. Now we're taking the fifth root of this quantity. So we need the fifth root of 243. We already did that above. That was 3. Okay, then we have this quantity x plus 2 to the 15th. And we want to take the fifth root of that. So what do I end up with? That quantity x plus 2 to the 3rd. Do I need absolute value bars for this one?
No.
No, I do not. Why?
Because it went from odd to odd to odd.
Yes. I started with an odd root. I had an odd power. I ended with odd. You don't need absolute value then. No, you can't. That's wrong. Okay, you always have to check to see if it's an even root, an even power, resulting in an odd. Okay, that's the only case where you need absolute value. Okay, questions on those examples?
No.
All right, last one here. The surface area of a sphere can be determined from the volume of the sphere using the formula S equals the cube root of 36 pi v squared, where v is the volume. If the surface area of the sphere is about 214.5 square inches, we want to determine the volume. So all I need to do is plug in 214.5 into S because that's the surface area. Okay, so I have 214.5 is equal to the cube root of 36 pi v squared. Now all I want to do is solve for v because that's the variable in my equation. Do you know how to get rid of a cube root? What should I do to both sides? If it was a square root, what would you do to both sides? You want to raise it to a power. Okay? So to get rid of this cube root, I'm going to take that whole quantity, raise it to the power of 3. Okay, whatever I do to one side, I have to do to the other. Okay, that way this cube and this cube root cancel each other out. Okay, so I have this 214.5 cubed. Yes, that is a very large number. And I'm going to write it out. So it's 9,869,198.625. Okay, on the right-hand side of my equation, I canceled out this cube root and this cube, so I'm left with 36 pi v squared. From here, all I want to do is solve for v, right? So what should my next step be? Don't subtract. I can divide by 36 pi. Okay, 36 pi is multiplied into v squared, so that opposite operation would be to divide it out. Okay, so I'll divide both sides by 36 pi. For this one, you get 87,262.87475. That's equal to v squared. All right, so now what do I do? You take the square root of both sides.
Why was this even a problem?
Because you need to know how to solve problems with a cube root. What?
I don't need to solve that.
I mean, I rounded to the 10th. So once you take the square root of that 87,000, you get the volume to be about 295.4. And that'll be in cubic inches.
Okay.
Yep. Okay, so the reason I had you do this problem was so that you know how to solve if you have a cube root or if you have a fifth root or if you have a fourth root. Okay, you want to raise it to that power so that you can cancel it out and then solve from there. Okay, does that make sense?